graphics that you have on your brochures is in very small font on the left lower side there, simply because I'm not going to talk about it. I'm going to hijack the presentation to talk about something that I believe holding us back more than the particulars of whether and how we use manual or fraud analyst and how we combine them, but it also touches this point. So what we do, and we'll run through it in few slides, is catch fraudsters during online transactions. You buy something, you press the action button of commit to buy, and within sub-second we tell the merchant whether to approve or decline the transaction. So it's an easy and standard classification problem, right? Not exactly, and I will talk about the challenge here and what's the general lesson, at least to the extent I have it. So what's the problem? The problem is a classification problem. We have good orders that are blocked or declined, which are the false positives. We have fraudsters that are getting in, and in the middle, in the classical operation of the merchants, there are very manual reviewers or pending decisions and so on. This is a big problem. The big problem is overall about $270 billion a year in losses. Now, do you see it well, or should we close the lights? Can you turn the lights off? Okay. So the reality is that the big merchants think, Home Depots think, the Walmarts of the world need to be fraud prevention experts. They can't really do that, so what we offer is a decision as a service. So in real time, for each transaction, we give an approve or decline decision for 100% of the payments. Doesn't matter whether it is by PayPal or by credit card or other payment methods, including Bitcoin, and we give 100% guarantee. If it's fraud, it's on us. So our false negatives are pretty costly. In other words, we build the human story to assess the trustworthiness of the person in internet scale. The spoiler here is that the human story is complex and it's hard to model. We cannot throw all our features or attributes into a logistic regression. It will take care of it. Another spoiler is we do not have a lot of data. Big guys in PayPal don't have a lot of data. There is never enough data. If there would be enough chargebacks, that is fraud data, we'd go out of business, right? So there is not enough data. So something I said? Okay. So there exactly. Once I said small data, all the data scientists are out of the room. Ask someone to make a siren to be polite and so on. Okay. So, but where the problem really lies. Now, if you work alone and not in an organization, and you work on simple problems, I guess you wouldn't be here, right? You work in organizations. But when we work alone, each one of us sees himself like this, something like this, right? It works, we get things done, we work. Once we get into the organization, we look more like this. We never get there, my stuff didn't get to production. All of us did great things in the academia, and suddenly we are bogged down in very many small challenges, which are delivery challenges down the road to production, or tools challenges, and so on. Why is that? I think that the answer to that is very important for us to acknowledge, so we can take care of it. Now, what's the real problem? What? Libraries of books and consultancy firms attempted to answer that. So people say, this is how the good team should look, this is our team, this is how our previous company looked, right? And invent a lot of architectures and services just to decouple problems. Is the problem scaling up? We have a lot of data. The problem is not scaling up because we do not expect it to be the solution anymore. In the last 10, 12 years, we do not expect it to be the solution. Is the problem the scale out? Well, scale out is not the problem, is not a big problem, because everyone needs to scale up. Many companies are doing internet scale work, and there is an ecosystem of tools to help us do that. The issue is the complexity of both logics and human processes. We have engineering, we have QA, you have data science, we have BI, we have research, and we have analysts. And the data scientist is twice or 3 times removed from the actual code in production in many cases. So what's the solution to that? The complexity of both the logics needed and the organization flows is a hard problem. If we acknowledge that, we'll find that it's harder problem many times comparing then, say, the real-time constraints or the availability constraints or the scale-out and throughput constraints, as long as we can solve them without adding to the complexity. So how can we solve it? And we'll dive into each one of these directions in separate slides. First, by engineering. We want to control how the data is flowing, how the information is flowing. And things need to be deterministic. Data services usually will not do that. Second, we can solve it partially by data science. And third, by data science flow into the production systems. Let's look at it. By engineering. What you see here is the graph of 300 and something processes of Folter's transaction. That's how each transaction looks. A lot of them are in parallel. There are a lot of joins of different processes that runs in parallel. We have actually unique algorithms to calculate how long should such a join wait for all the data it needs to get from different nodes or sub-processes. What is important about that is that it exists. So we know how the flow looks. It is self-documenting. We know each of these nodes where it sends its data, where it gets its data from, And that enables us to grow the complexity and grow the information, the complexity of the logics of the information flow without degrading the availability and the performance. This graph will tell us whether we have a problem with any one of them. Now let's look at the data science itself. In the real world of fraud prevention, we have very many attributes. Each one of them is not extremely telling by itself. But if I would look at the billing neighborhood and the shipping neighborhood and look at how the median of income difference is behaving between them, I may find strong correlation with fraud. Well, this could be an attribute, but there are many more of these. So I need to decouple the dependency among them. I'm not talking about correlation. Every SVM or logistic regression will solve the issue of correlation, the issue of several attributes which are not orthogonal to each other and are actually pretty much relying on the same data and saying the same thing. I'm not talking about this case. I'm talking about coupling where one attribute may entirely change the semantics of another attribute. For example, getting back to the previous lecture from PayPal point, if I would know that this is a proxy, well, that changed the meaning of where it is, right? So if it's a proxy, it's no longer indicating the location of the actual person that is browsing the web now, and so on. So we want to decouple our attributes. This could be taken as a deep learning level 1, but we want to give the unobservable coupling variables a human readable form. For example, if I'm looking at these attributes, they will be very much decoupled if I would only know what's the social economical status of this person. Now, of course, now I need, if the story is that this person is rich, I now need to normalize over all the available stories and to see whether each one of them, or to what extent each one of them is plausible. So if this is what we want, and I'm not stopping there, this is what we are actually. Doesn't matter, everyone can normalize over attributes. The second thing is strong recommendation, and that's the right way to do that. Separate your decision, should I approve or decline the transaction, or whatever your decision is, separate it from the inference. The inference will give you, given all the attributes and the coupling and the way you do it, it will give you the chance, the probability that this is fraud, or the probability distribution for whatever your question is. Given this probability, go and do a separate decision process, and this will clarify a lot, mainly about the way we insert our business considerations into the decision. In that way, you can also bake in much more discipline. The analysts, the domain experts, insert their knowledge into it. And last, by the way the data science is flowing into the production system. The first is make sure that all your non-technical people in the organization are technical enough. That is, I don't require them to be technical, but Python, SQL are basic. They need to master them. They need to be able to analyze by themselves any data from the analytical database. And they need to write and express their logics and what they say about the problem in code. Then they are, now that they learned this, we said, okay, now you know Python, you are responsible for your code in production. Whoa, in production, what about availability? What about all the exceptions that will lie around? Well, you are responsible for your code. We'll protect the system. We'll wrap around you all the try catches and all the special threads for you. But you are responsible for your code. And today, we get in minutes, using of course the continuous integration, continuous deployment, we get in minutes every new insight of an analyst into the production system as needed. Second is the flip side. We need to use the frameworks that enable us to encapsulate and protect this code of the domain experts. We use Storm. As with any framework, when we started to use Storm, and as we progressed, we understood that it is less developed and mature than what we hoped for, but we matured everything that we needed, and we created the protected areas for them. And last but not least, there are good tools emerging that acknowledge this very problem of getting the data science to production without the bridging or the mediation of some engineering tools. A good example, which I think is spot on with its direction and concept, is the GraphLab predictive services by Dato, and but there are others. For example, we get now our analysts to write directly on Spark. It's hard. They are clicking, they are screaming. So, can we eliminate fraud? I have to put this slide, right, because this was the title of my talk. Can reduce and contain it. We don't attempt to eliminate entirely. Can we eliminate fraud analysts? We do not want to eliminate fraud analysts. Neither we nor PayPal nor others have enough data in order to just let the data speak. We don't want to eliminate fraud analysts. We just turn them into fraud analytics researchers, and they are part of the production system. And last, but can we efficiently use them? After a lot of thought and investment, we can. Thank you very much.